5, and welcome to our first afternoon session of the OSGi community event for today. My name is John Eric. I'm the Executive Director of the OSGi Alliance, and I know I recognize some of you out there as members of the Alliance, and if you're not a member, certainly would love to have you become a member. I think we're doing a lot of great work at the Alliance, and we can always use help. And I would encourage you to go to our website, osgi.org, and check us out. And if you could become a member and help us, well, that'd be fantastic. So, again, welcome and thank you for attending. And it is with great pleasure that I introduce Tim Ellison, who will be presenting this afternoon on modules all the way down. OSGi and the Java platform module system. So, Tim is currently a senior technical staff member with IBM's Runtimes Technology Center in the UK. He has worldwide responsibility for open source engineering in the Java SDK, underpinning a broad selection of IBM's flagship products. He was part of the original Eclipse development team and has been a vice president of the Apache Software Foundation and chair of the Apache Harmony Project Management Committee. He is currently a member of the JSR 376 expert group, designing the Java SE platform modularity system. Tim has a BSc in computer science and an MSc in computer science from the University of Manchester. Please join me in welcoming Tim. Thank you.
Thank you, John. Raking up all my past. I only have 35 minutes to do cover quite a lot of material. So, I have some charts here. The charts will be published. And if there's any questions, I'm happy to have discussions outside of the formal discussion. So as John mentioned, my name is Tim. I work at the IBM Runtime Technology Center. We used to be called the Java Technology Center. We kind of branched out into other languages. And today I'm talking about a particular aspect of the work that I do there around modularity. Now, modularity in Java has got quite a long and you can't. Come on, sit down. That's it. Yeah. Go ahead. Modularity and Java have got quite a long and checkered history, and there's probably at least a 35-minute talk about, how we almost implemented modularity a number of times and some of the various positioning and plays that went on around modularity for the Java platform. It kind of goes all the way back to 2005 when there was a JSR, and the JSRs, for folks that aren't familiar, are the specifications for advancing the definition of the Java platform. And 277 was initially described as a way of an all-singing, all-dancing version and modularity system for the Java platform. And it never really got off the ground because 291 came along, and that was kind of a recognition that trying to build a whole new module system from scratch probably wasn't such a bright idea when OSGi already had a lot of history in this space and had solved a lot of the problems. And so 291 was an attempt to say, let's use the OSGi model for modularizing Java itself. And for various reasons, not technical reasons, for various reasons, that JSR also didn't proceed. There was yet another attempt at 294, which was a much simpler approach, defining super packages into Java. But what we've ended up with is, in OpenJDK, you've probably heard of the Jigsaw Project. And the Jigsaw Project is a place at which there will be a number of pieces of technology which all go towards developing this modular Java platform. It's an attempt to try and bring together all of the various different aspects that had been discussed earlier, and also I recognise to try and get this stuff working with OSGi as well. Now, it was called Jigsaw originally. That also had a bit of a failed start, and so the work has been taken inside house at Oracle. They did a whole bunch of work on it, and then they kind of released some code and some specifications, some descriptions out to the community, and that kind of restarted work has been called Jake. It all begins with J, I guess. So as of today, the latest code is available from the Mercurial repository at the URL on this chart, and the discussions take place on something called the Jigsaw dev mailing list. Now, modularity in Java 9 kind of means different things to different people, because it's not just the actual resolution of modules that it covers. That Jigsaw project also encompasses restructuring the code base so that functionally equivalent areas are put into the same sort of place in the repository, defining what those functional areas are, and redefining what the JRE and JDK will look like. So come Java 9, there won't be a distinction between a Java runtime and a Java development kit. It will just be a Java 9 installation where you have got some of this additional functionality added in. And you'll notice things that get moved around and changed a lot as well. So there's no monolithic rt.jar. There are differences in class path, etc. we'll talk about later in the talk. So Java 9 is going to be quite a change to what people have got used to over the previous releases of Java. For the purposes of this talk, I'm not going to be discussing all of the other sort of periphery activities around this. I'm going to focus on the work that's actually going on in JSR 376, and that's defining the platform module system, and then doing some comparisons between that JSR and what OSGi provides today. So the two main goals of the JSR can be specified very simply. One is we're aiming to provide a reliable configuration of programs, and that is kind of recognizing the fact that the class path as a linear search through a bunch of jar files is very fragile. Everybody's heard of class path hell as a means of trying to organize your application into a coherent set of jar files. And the other main requirement is strong encapsulation. So again, here, a topic very familiar to folks with OSGi background is ensuring that a module can only export the APIs which it's going to support as public APIs. And any internals and internal APIs which are not intended for consumption outside of that module are well hidden. And so these are the only two, as I say, principal requirements which are defining the Java platform module system. So how is it implemented? Well, very basically, modules are going to be a new top-level component in a Java program. So today you've got classes and interfaces and packages, all as first-class citizens that you can reference from your Java runtime. Well, this JSR is introducing a new concept, which is a module concept. And along with that, these modules will have some capabilities which are enforced by the VM. By convention, modules will be named in a very similar way to packages. So when you start seeing modules with com.example.app, that kind of naming convention, these are modules which are defined by end users. Module names that begin with Java dot will be those which export a platform API, and those which are JDK dot are implementation modules. So those are sort of reserved namespace for the platform itself. And then when you're declaring a module, you'll start to create source code in a module info.java. And here the analogy is with the package info.java, if folks are familiar with that already, describing the capabilities of the package. Well, module info.java, you put it into the module root directory, and then you use Java-C to compile it down to bytecodes. Okay? One of the big caveats here is that in the current definition of the JSR, this module info.java doesn't have any user-defined areas. It doesn't have any space where you can squirrel away extra information over and above that required by the module system itself. And it also doesn't allow any annotations on it as well. So this is an area of debate at the moment as to how extensible this module info. And there's a balance between the expert group trying to ensure that it's kept very simple, but also meet all the needs of a fully fledged modularity system. And so as I go on to talk a bit later on some later slides, my expectation is that tools will be using this module info.class to glean information about the modules. And in fact, we probably expect to see some tools generating these things directly rather than people hand coding them. So here's an example of a very simple module declaration. And this begins with Java dots, so that says that it's one which is part of the platform, and it's exporting some Java platform APIs. And in the module info.java, you can see we've got the new keyword module. It's declaring this one to be called Java-based, and it is exporting a whole bunch of packages, and these are all API packages. So that's pretty straightforward. Now, as an application developer, I come along and I want to put a dependency on this module. And so in my own module info.java, I've got my application, example.app, and I have a requires statement which says I require the APIs in java.base. Okay, so that's a reference back into that particular module. And in turn, I export some packages from my own module. Now, the immediate thing that you'll notice here is that the requires statement is a requires on a module, whereas my exports is exporting individual packages. Okay, so there's an asymmetry there, which is kind of interesting. And although in this particular case, I've said that I require Java base, and of course I could have any number of required statements in there. Everybody requires Java base. Java base is the root of the dependency tree, and so even if you don't specify Java base, you get that as automatically required. So let's compare that with OSGi. Again, a requires on a module. There's a very strong analogy with require bundle. So folks who are familiar with OSGi, which I assume is most people in this room, have a dependency on a particular bundle. You'd use the require bundle header in the manifest. And similarly, there is this concept of readability. So now that I've put a requirement on that particular module, the term is that that module becomes readable to me. So I can actually see things which are in that scope of that module. Readability isn't transitive, so obviously if somebody puts a requirement on me as my APIs, they don't get to see things, well, okay, it's a bad example because they are in the base and everybody gets to see the base, but they wouldn't see a transitive other things which I required. And so the JSR spec says that you would use the keyword public here, so you say it requires public, some module name, to pass through the dependencies that you have already seen. And again, if you compare that with OSGi, the require bundle visibility re-export is the equivalent of that. So that's the very simplest way in which you would declare modules and you'd have dependencies between them. So now you've got lots of modules that you started to create, you put dependencies between them, and of course you want a runnable system. And so the well-formed set of, an application which is a well-formed set of modules, a coherent set of modules, are specified at runtime by using a module path. So if you look at the example on this chart here, we have using the keyword, I beg your pardon, the Java launcher here, it becomes a -mp for a module path with a list of directories and then the name of the module which is going to have the main in which you will launch it there. And so here what we've ended up with is somebody somewhere has assembled a set of modules together which are known to work together, and specifying the module path tells the launcher these are the places where you would go and look for all of the modules which are required by my particular application. Of course, one of the risks here is that you've just traded the class path hell for a module path hell. And one of the limitations, I guess, of JSR 376 modularity is that it's not dealing with the problem of assembling together a coherent set of modules. Okay? That problem has been delegated out to external tools. And so if you read the state of modularity at the moment, they're saying, tools like Maven already worry about how to bring in the correct versions of all the different libraries and dependencies that you have, and they can assemble those together into a working system. Then when you launch Java, you will get just the modules which are required and that are shown to work together by that high-level description to Maven. And in particular, it's sort of calling out that version information is not part of the JSR 376 modules. So those modules can carry some version information with them, but they're not considered when the modules are being assembled there. what would happen if you have a module missing, or if you had two modules with the same name found on that module path, is that you'd get a compile time or a runtime error, depending on when they were seen. Okay, so lifting the covers a little bit, I said that we've made some changes to the VM to enable this modularity to work, and that's something which OSGi never had the opportunity to do. So if you look at the class loader hierarchy, there is a difference in the way class loaders are managed between OSGi and the Java platform modularity. So in OSGi land, you have an OSGi environment class loader, which delegates up through the system class loader, extension class loader, and bootstrap class loader. And then there are a number of instances of class loaders, each associated with a particular bundle. And each of these class loaders knows which, it's, part of the bundle information tells it which packages are imported by that bundle and what its dependencies are, and which class loader is responsible for loading that particular type. So that when you have references in your code to particular types, you'll go off to the particular class loader, and there's sort of a net between these, which goes off and loads the class from the appropriate one. Obviously, if it's a Java platform, then it will get delegated up to the bootstrap, as before. In JSR 3.7.6, the goal here was to maintain the existing class loader hierarchy and kind of recognize the fact that things like app servers have got pretty complex systems of class loading already. And so it just maintains the existing set of class loaders orthogonal to the modularity system. So the only difference here is that the extension class loader and bootstrap class loaders are used to load the platform modules, and the system class loader is used to load things which are on the module path. There's a slight tweak in Java 9. The extension class loader no longer grants all permissions to types that it loads from there. And some of the system classes have been moved around from between extension and bootstrap. Things have been sort of pushed down to remove some of their all permissions for security reasons. Again, I want to just kind of draw an analogy here. So down at this module knitting layer, it's all very well to have trying to get this coherent set of JSR 3.7.6 modules loading together. OSGi kind of operates at a higher level, right? So this allows applications to not only deal with the versioned information, but also to base things around services, more so than actual concrete class implementations. And so the coupling together of your application is a lot more dynamic, not only because you have the whole life cycles of modules coming and going, but because you've got dependencies on services more so than you've got dependencies on explicit modules. And so your application, rather than being defined by this module path, which kind of says how you've got a coherent set, is defined by the entire framework here, right? But some good news is that the module information, because it's in this moduleinfo.class, can be stored alongside the metadata information which is stored in the manifest. So if you had to look inside a jar file, you could actually use the same jar file both as a module for the Java platform, by including the moduleinfo.class, and as a bundle for OSGi by putting the information in the manifest. Of course, the problem with that is that there will be some overlap, there'll be some duplication of information between the manifest and the module info. And you'll have to make sure that stuff is coherent and synchronized between the two of them. Looking at reflection, well, the JSR does give you lots of opportunities to sort of punch holes through the module system. And so if your application is written in a style which requires some access which it doesn't have by default through the module specifications, then there are lots of new APIs granted through the reflection API set which allow you to modify these things at runtime. Again, subject to a security manager check which will be in place. But if you have the rights to do so, then you can go and you can add a read relationship to another module. So using code like this here, you can get a particular class can ask what its module is, and it can say that to add a read relationship back to some other module. And then you can even go and you can add exports between modules as well using the reflection API. So if you have the rights to do so, you can actually bypass and augment a lot of the information which is stored in the module information and build a much richer set of dependencies than you can directly from the meta info. Although you can add those exports and reads relationships, the accessibility is unchanged by that. So, if you have access to an exported type, you'll still be held to the public and private responsibilities that the compiler and VM enforce upon you. And so you'll get errors and illegal access errors if you try and reflect into those things. In OSGi, the visibility rules are the same, but as we kind of point out here, once you've got a reference, you can use reflection to set accessible and start to manipulate some of the types and fields in the code that you have dependencies on. The other area I wanted to quickly touch on is the service model. So there isn't a huge change to the service model for the Java platform module system. It's still based upon service loader. Services say that they use a particular service interface. So here I've got an example from the Java management module. You'll see it's got some requires public, so it's passing through the RMI APIs. It's got a requirement on logging and naming locally, and it exports a whole bunch of different packages. Actually, there's an example here of where it exports. It has like a concept of a friend relationship, so you can export a package just to named modules. And then the service statements are down in this shaded box here. So the Java management uses JavaX Management Remote JMX Connector Provider, and it provides this interface with this concrete implementation. That kind of makes sense to folks. So as a service user, you say that you have a dependency on typically a particular type of interface. And the runtime, when you go to compile this and when you go to run it, will look for somebody who is providing that particular interface with a concrete implementation and match those two things up. The problem is that, of course, these are done sort of statically, and you just get one chance to provide a particular implementation. And as we were discussing earlier, there may be times at which you would like some flexibility over the object that you're providing that particular interface with, whether it's shared across different modules or whether it has options that you want to be using for the factory to create things in a slightly different way. But in this particular model, they are kind of statically defined and statically resolved, the implementation and the uses of interfaces.
And they're global variables.
And they are global, yeah.
Statics.
Yep. So looking for some opportunities here, I think, for how we could get OSGi and the JSR 376 stuff to work together nicely. I don't think it's going to, part of the goal of the JSR was to make modularity simple for all of the Java developers. And I think the fact that you can see the history of the modularity system and the way things have evolved is that some of the simplicity has been gained by saying, it's just not my problem, I'm going to delegate that out to some other tool to solve it for me. But I think, it is a naturally non-trivial problem to solve modularity with version and configuration management. And I think people that come to Java through the Jigsaw APIs are going to pretty soon realize that they need to have some of this kind of capability for version controls and the dynamic life cycles of bundles and so on. And so what we're going to end up with is a subset of the data, of the metadata that you actually need being specified in the module declaration. But in fact, quote, the real metadata, the stuff that's actually required for the level of complexity that we have here, is going to be out in some other representation, whether that's a POM XML file or whatever. There's going to be somewhere where you have got all of the information required to bring together your application as a coherent set of modules and not just rely on the simple module information and the module path. And so perhaps the opportunity here is to say, well, you know, we don't really expect people ever to be hand writing these module information for the JSR modules, that we'll actually always go back to the canonical source here and generate from that both the OSGi metadata and the Java platform metadata from the original. And that will, of course, keep it in sync. I mean that we just have one place in which that takes place. I think the other opportunity here is that OSGi at the moment has got a dependency on running on standardized platforms. And so today, whilst you can have a dependency on capabilities of the platform, eventually it all boils down to you actually running on an implementation of SE or ME that has been defined by, you know, the JSRs for each of those particular platforms, which may have a lot more functionality in it than you actually require. And so necessarily, you know, with 376 coming in there, it's going to give you the opportunity to have applications depend on a subset of platform functionality. So if you don't require some SQL capabilities or you don't require XML capabilities, etc., it will be much easier to leave that stuff out in a Java 9 world than it ever was before in the earlier Java implementations. And so we can have a much finer set of runtime dependencies between the OSGi bundle declarations and the platform, to the extent where, you know, perhaps we can put specification, it would require an extension to OSGi, but perhaps you could have a dependency on specific platform bundles rather than execution environments, or you could even interpret Jigsaw modules as virtual bundles themselves. And I guess the final message here is that it's not all doom and gloom. I think you know, one of the great advantages here is going to be that it gives visibility into modularity to more Java developers. And as more people start to think about modularity, I think that actually is a natural on-ramp for people to, as I say, get into an OSGi model and figure out that what they're looking for is something which is a bit more service-oriented and has this lifecycle management and some of the, you know, additional capabilities that have learned through the history of OSGi over many years. At the moment, a lot of people are going to static repositories to pull down jar files at Maven Central or wherever. You know, that could well be a place in which we end up with a Java module repository, which really becomes a de facto source for being able to dynamically download and link a whole bunch of Java modules, whether they be, you know, just Java modules or Java modules with OSGi metadata in there as well, so you get the best of both worlds. And all this will be coming, hopefully, in a Java 9 timescale towards the end of next year. So thank you very much for paying close attention to it. Any questions partway through? If there are any questions now that you'd like to fire at me, feel free to, yeah.
A question regarding class loading, because you said that it's possible to add dependencies at runtime.
Mm-hmm.
Can this cause circles?
Yeah.
Cause circular dependencies?
Yes. So the question is, because the reflection APIs have been extended to allow additional exports and reads, can you add cycles? And the answer is yes, you can. Yes.
And it can deal with it?
They call it Stack Overflow.
Yeah. Yeah. You can do whatever. You can do whatever with those. Yeah. Yeah. You end up going around. You can end up going around. Yes, sir.
Do you think that this will scale for more than just the platform? Because if there are no version information, and you have, for example, have a look at Eclipse and just install a few plugins, you'd be amazed how many versions of
Yep.
you have, right?
Yep.
And again, like just with a few libraries or frameworks, you get inconsistent dependencies.
Yep.
So do you think that this will scale, or do people will use like version numbers in their module names?
Yeah. So just repeating the question for the purpose of the recording here is: do I think it will scale without version information being available? And your point was that many existing systems like Eclipse kind of have already demonstrated that you end up loading lots of different versions. The short answer is I think it would be very hard to scale. and that people will start to add additional information around the modules to try and get some, some level of versioning information into a module. But it's going to be painful. And I think the lesson will be learned the hard way, that really you do need versioning information as a first-class piece of metadata to be able to get coherent systems. The concept of being able to define a module path for an application which satisfies all of the versioning requirements, I think is not sound. Yeah, we're out of the bang.
Yeah, just wondering, does Jake support any kind of dynamicity, meaning that you can uninstall modules and it can reinstall newer versions of them at runtime? Is that something they're going to support?
Okay, so the question was, does the system support any sort of dynamic nature of module loading and unloading? No, in fact, a lot of the discussion that I have seen is actually about pre-linking. So they're actually more interested in being able to determine much earlier in the cycle as to which modules you're going to be using and hard linking that. So perhaps if you have a closed world assumption, being able to lock down the specific versions of modules that you have and do some JIT optimizations on the code, AOTing the code beforehand. So I think a lot of this is with a view to embedded devices, right, and being able to produce as small a runtime as possible. But I've not seen any long-term discussions around life cycles of modules. Yes, sir.
So you talked about using some kind of common set to generate both metadata files for OSGi and for the new modular system. Okay, that's fine on the administrative side of things. At runtime, now we have generated those metadata files, and they're both in use. Once we run OSGi in Java 9, they're both in use at runtime. How, I didn't quite understand, how does this marry up? I mean, I have my 50 bundles, they have dependencies. I declare them in some fashion to metadata, the module class, and the manifest generated out of that. Now both Java runtime and the OSGi system on top of it interpret that, and it's kind of double work, isn't it? I mean,
right. So the question was, how does moving the metadata into a common form that emits out into both Java platform metadata and OSGi metadata help in the complexity of the final runtime? Is that a fair?
The question is, he thinks they're going to both be loaded. Jigsaw is going to load it with one set of metadata and OSGi with another. But I think the answer is that it'll either be used as an OSGi bundle and loaded by OSGi, or it will be used as a Jigsaw module and loaded by the platform. It will never be loaded by both simultaneously.
Right. So
OSGi can create a module anyway to get the extra protection.
Yeah. So my point, as BJ pointed out, it's not that an individual module would play a role of both simultaneously in a particular runtime, but it could be either or. Right. That if you were running it in an OSGi environment, you'd have the metadata available, or if you're running it in the Java platform module system, you'd have that same equivalent sort of metadata available.
So this means Java dependency now is not solved by Jigsaw.
it's ignored.
For me, it's an advantage to have different versions of Google Juice in my code, so they don't interfere with each other. But can you briefly describe why didn't they choose OSGi? Why did they go with something they discussed 10 years?
Off the record.
Turn the mic off.
Is it licensing?
So the question is, if this hasn't really solved the module hell problem, why didn't they use OSGi? And I don't think it's a licensing problem per se. The goal of the Java platform module system is to provide a simpler module system. I think the folks, the architects in Oracle did take a look at OSGi and considered it, and my understanding is that they considered it was to be too complex for the task, because the Java developers in general would not need the full power of OSGi. I think they've then gone on to design a system which may well lead people onto the capabilities of OSGi in time, but I can't explain why they don't think they're going to get to that point.
So we will see people implementing their own class loaders still and so on. Just a last question. What does this mean for pre-Java 9 applications? Will they be executed in some kind of compatibility environment? The base package is default loaded or something?
right? So applications that were written before Java 9, so if their expectation is just to use the class path, then there is a concept of an unnamed module. So all the jar files that you specify on the class path will get wrapped in a virtual module, which is called the unnamed module. But that's kind of beyond the scope of this talk. Say again?
The module that shall not be named.
The module that shall not be named. All right, I've been given the stop signal, so thank you very much for your questions.